Hi folks, we're going to take a look at number 36 from page 421, and this is a really nice problem because we're going to see how we can generate the cosine law using vectors as opposed to the way you would have done so in grade 10 by splitting it up into two right angle triangles, and it would have been a fairly long drawn out process. Okay, and we're going to see here that this is just going to take a few steps. Now they give us a hint. Okay, they tell us to use the fact that the magnitude of a vector squared is the same as the vector dotted with itself. Okay, so we have to figure out how to incorporate this. So I notice here, they're telling us to work with vector c, which sort of makes sense from my diagram since I'm, trying to find this angle theta. Okay, so let's think about what we would have on the left-hand side of the cosine law. Well, you'd have the length of the side opposite to the angle squared. Okay, so we definitely want to work with this length squared. Okay, so that's a good start. Question is how do we incorporate a and b? So let's look at how this diagram is formed. Okay, it looks like you have vector a plus vector c is equal to vector b. So you have a plus c is equal to b. Okay, based on the diagram. Okay, but since we want to work with vector c, okay, let's isolate vector c. Vector c is just equal to vector b minus vector a. Okay, so now let's start setting up our equation. So we know on the left-hand side we're going to want the magnitude of c squared. Okay, but that's the same as c dot c. Okay, but now what we can do is we can take the alternative expression for c, which is b minus a, and that'll allow us to do some algebra that involves the other two sides of this triangle. So c is equal to b minus a, okay, and dotted with c again, which is also equal to b minus a. And now we notice that everything on the right hand side now involves the other two sides of the triangle, which is exactly what we want. Okay, so let's do the algebra. Let's start by distributing. So we have b dot b. Okay, we have plus a dot a. Okay, and then we have minus b dot a. Okay, and then minus a dot b. Okay, but b dot b is just equal to the magnitude of b squared. A dot a is just the magnitude of a squared. This just gives us, since we have commutativity of this operation, is just minus 2 times a dot b. Okay, so here, to make it look more like the our usual view of the cosine law, I'll just switch these around, which I can because it's addition. Okay, and here, well, what is a dot b? It's the magnitude of a times the magnitude of b times the cosine of the angle between them. Hey, what's the angle between a and b? Hey, a and b are already tail to tail, so it's just that theta. And I think what we have is we have a proof for the cosine law, because here you have theta. Okay, on the other side we have the length of the side opposite to theta squared, and then here we have the sum of the other two side lengths squared minus 2 times the two side lengths times the cosine opposite to c. And there we have it. We have the cosine law with a much easier, or at least a much shorter proof than you would have seen previously using trigonometry. Okay, that's it for this one.